So guys, now let us try to understand that how Twice NAT works. So our problem statement is that XYZ Corporation wants all of its internal users to access the DNS service which is offered by Microsoft rather than DNS service which is offered by Google, right? But some users within the XYZ Corporation could be notorious and they can configure their own machine to contact the Google DNS server instead of Microsoft DNS server. So how can XYZ Corporation solve this problem? That is, even if the notorious internal user of XYZ Corporation try to access the Google DNS server, the firewall must do something that instead of contacting Google DNS server, the internal user automatically contact the Microsoft DNS server for resolving their DNS queries. Right? So let us see that how an administrator can install the network address translation rule on its firewall in order to enforce this constraint on internal users. So let's say that user 2 is a notorious user, right? And he generated DNS query which will go to Google DNS server. So user 2 is a notorious user and he is trying to bypass the XYZ Corporation policies, right? So in an attempt to contact the Google DNS server, obviously the destination IP address would be the IP address of the Google DNS server, which is 100.0.0.2, right? And source IP address would be its own address. Source port number would be something which is randomly generated by the application running on user 2 local machine, and destination port has to be 53. It is the user 2 responsibility to contact the Google DNS server on the right IP address as well as on the right port number. So DNS service which is running on this Google DNS server is listening on the UDP port number 53, right? So user 2 has to contact the DNS process which is running on Google DNS server on UDP port number 53. So 53 is something which user 2 has to specify while connecting to Google DNS server. And of course the underlying protocol is UDP. The DNS service works on top of UDP protocol. So this is the packet, the original packet that is generated by user 2 machine, right? And when this packet will cross the firewall boundary, the packet will undergo translation, right? So this is the translated packet. And you can see that the packet has undergone translation. Let us assume that the administrator has installed the network address translation rule on its firewall. Now what are those rules? I mean, in terms of configuration, we will going to look into that later, but let us first understand the concept. Now you can see that the source IP address has been converted from private IP address 10.0.0.20 to public IP address 100.0.0.1. So it could be any public IP address which is purchased by XYZ Corporation. In this example, I have just taken the public IP address which is assigned to outside interface, but there is no as such any compulsion to take an IP address of an interface. It could be any public IP address which is purchased by XYZ Corporation. Alright. The destination IP address you can see that it has been translated from 100.0.0.2 to 100.0.0.3. It means that this translated packet would go to Microsoft DNS server and not to Google DNS server as per the destination IP address, right? Now this source port number is something that is randomly generated by this firewall, right? The original source port number has been replaced by the source port number which is dynamically or randomly generated by the firewall device, right? So you can see that even source port number is undergoing translation and destination port number remains unchanged. How can firewall change the destination port number? Because at the end of the day, the service, the DNS service is running on a standard port number 53, right? the protocol is unchanged. So you can see in this complete translation, the source IP address has been changed, the destination IP address has been changed, the source port number has been changed. So both the port numbers as well as the IP address are undergoing change, therefore it is called Twice NAT. Similarly, it is another example where a notorious user 3 is trying to contact the Google DNS server, but the network address translation rule which is installed on this firewall do not let that happen. It updates the source IP address, the destination IP address and the source port number of the packet such that the packet, instead of going to Google DNS server, it will go to Microsoft DNS server. Alright, because the destination IP address has been changed in both the scenarios. And we already know that any packet which traverses over the internet have a source IP address and destination IP address always as public IP addresses. So in this case, you can see source IP address is a public address, destination IP address is also a public address. Right? So this is an example of Twice NAT where the packets are undergoing translation when they crosses the firewall boundary from inside interface to outside interface. So going forward, so this is the same translation that we discussed on the previous slide. Nothing has changed, right? And we already know that when the ASA firewall performs translation on the packets which are going from its inside interface to outside or vice versa, it populates an internal table called translation table, right? So this is the translation table, a data structure which is maintained by firewall when it performs translation over on the packets which is passing through it. And in this translation table, it keeps a track that what has changed to what in the packet. So here is the real IP address, this is the real source port number, and this is the real destination IP address, the real destination port number, right? So this is the real source IP, this is real destination IP, this is real source port number, this is real destination port number. And after translation, we call the translated fields as mapped fields. So this is the mapped source IP address, mapped source port number, and mapped destination IP address, and mapped destination port number, right? So you can see real destination port number and mapped destination port number is same. It means that destination port number has not undergone any change, whereas rest of the fields in the packet has undergone translation. So the first entry in this translation table is for user 2 and the second entry in this translation table is for user 3. Alright. Now the next question is that when this MSDNS server respond back, then how this firewall knows that how the content of the packet should be replaced so that this reply can be forwarded to the correct user for which this reply was intended for, right? How firewall would know that this reply is for user 2 and not for user 3? So that is the thing that untranslation would take care. And untranslation happens using this transition table. Now, these are the packets which are replies generated by Microsoft DNS server. The source IP address would obviously the IP address of the DNS server. The destination IP address would obviously the IP address 100.0.0.1, right? Source port number would now become 53, destination port number would now become 32. So if you compare it from the previous slide, you have to swap the source IP and destination IP and source port number and destination port number in order to generate a packet which is a reply from DNS server. And the same thing I've done here. Simply swap the source and destination IP address and source and destination port number. So this packet is a reply packet which is generated by DNS server, and this reply packet is being targeted towards firewall of XYZ Corporation because destination IP address is 100.0.0.1, which is a public IP address owned by the firewall. So when this packet hits the outside interface, ASA firewall will now use this translation table in order to generate the original packet, original reply packet, right? That is, this is the packet that is coming on the outside interface. Now how firewall will going to replace the source IP address, destination IP address, source port and destination port number in the field, so that the packet would undergo untranslation successfully and could be delivered to the right internal user, right? So you can see here, this is an algorithm to perform untranslation. First of all, the firewall will find a row in this translation table which would be used to generate an untranslated packet. Now how that particular row can be identified in this translation table? It will be done by using this first part of this algorithm. So the first part of the algorithm says that source IP address in the packet, that is this, must be same as the mapped destination IP address in the translation table. So mapped destination IP address is here and it is same, but it is same in both the rows. So let's go forward. Destination IP address in the packet, which is 100.0.0.1, must be same as the mapped source IP address in the translation table. So mapped source IP address in the translation table is 100.0.0.1 and it is still same. So still both the rows in the translation table qualifies. The third criteria says that source port number in the packet, which is 53, must be mapped to mapped destination port number in the translation table. So here is still both the rows in the translation table matches all the criteria so far. Destination port number in the packet, which is 32, must be mapped to the source port number in the translation table. So mapped source port number in the translation table is 32, and it is this entry which breaks the tie between the two rows of the translation table. So now we know that it is the first row which matches the corresponding fields in this packet, right? This is reply packet from DNS server, right? So once the row in the translation table has been identified, then the second part of the algorithm is executed. Now it's a time to replace the fields in this packet so that untranslated packet would be generated. And the algorithm says that replace the source IP address in the packet with the real destination IP address in the packet, in translation table, sorry. So source IP address in the packet is 100.0.0.3 and the real destination IP address is 100.0.0.2. So we can see this 100.0.0.3 has been replaced by 100.0.0.2. Similarly, destination IP address in the packet is replaced by the real source IP address in the packet. So you can see the destination IP address in the packet is replaced by real source IP address in the translation table. And similarly, the source port number in the packet has to be replaced with real destination port number in the translation table, and destination port number in the packet has to be replaced with the real source port number in the translation table. So this is the final packet which is generated after performing untranslation. So the packet which is generated by ASA firewall after untranslation is this packet. It will have these fields, and depending on the destination IP address, this packet will be routed by the XYZ Corporation intranet to the right user, right? So you can see this algorithm plays a major role in performing untranslation. If you look into this translation table and think about it, then you would find that this algorithm is quite intuitive or obvious. So in this complete transaction, the notorious user 2 thinks that he is happily talking to the Google DNS server, but in reality, he is talking to the Microsoft DNS server. User 2 would never know that he is actually talking to Microsoft DNS server instead of Google DNS server. But at the same time, all his DNS requirements are satisfied.